So when we talk about linear functions, we're talking about things that are functions, but literally we're talking about all functions that create a line when we graph them. So when we graph them, we know that they are going to have a straight line. We also know that it's always increasing, or it's always decreasing, or it's going to be flat. There is no movement on the y. And when we read a graph, we always read graphs from left to right, just like we would read words. So because we read graphs from left to right, we're going to say that this first example from left to right is increasing. It's going up from left to right. What's increasing? The x is increasing. The middle graph, because we read the graph from left to right, we would say that the middle graph, it is decreasing. What's decreasing? Well, actually the rate of change is decreasing. And on the third graph, we see that it is flat. It's a zero slope. The x is changing, but there's no movement on the y's. So this first question says, are the following graphs a linear function, y or y not? And we have this first graph. And I would say no, because this is not a straight line. It's curved. It's not a straight line. And because it's not a straight line, we know that the rate of change is not constant. What about the second one? Well, when graphed, it is a straight line. So I would say that this is a linear function because it's a straight line. And because it's a straight line, that means that it has a constant rate of change. Now, this graph, it is a straight line, but we have to make sure that it's a function. So I would ask the question, hey, does it pass the vertical line test? Does every x have exactly one output? Yes, it's a function. So yes, this is a linear function because it's a straight line. This has a constant rate of change. The actual rate of change is 0 because it's a flat line. So when we take a look at equations and we're trying to distinguish whether or not it's a linear function or not, you need to be looking at the x value. Does it have an exponent? Because it shouldn't if it's linear. And it also must have an output. It must have a y value. So the most common linear functions is y equals mx plus b, where m is a number. It stands for slope. And b is also a number, and it represents y-intercept. Another version of a linear function that you haven't really seen yet, and we're going to talk about next unit, is this ax plus by equals c. And it's just another way of showing us a linear function where a, b, and c are all numbers. So here are some examples of linear functions. You've got this one where it's that ax plus by equals c, because the a is 3, the b is -2, and the c is 12. This is a linear function. This one, we've got y equals mx plus b. M is a slope, b is y-intercept. And then number 3, it has an x value. The x value doesn't have an exponent, so far we're okay. And the y value, there is an output. So we know that there's a relationship between x and y, which creates it as a linear function. So this is a linear function because there's a y value, there's an output, and there's an x value that does not have an exponent. So yes, this is a linear function. This one has a y value, it has an output, but the x value is soon going to be squared, which means that the x has an exponent. So no, this is not a linear function. This one again has a y value, it has an output, it has the x value as an input. There is no exponent on it. The x is not on a denominator. It doesn't look anything like that. It kind of looks like that ax plus by equals c. It's just solve for ax. So yeah, this is a linear function. So if you take a look at x equals -3, I'd say no, because there is no y value. There's no output. The only thing that we see here is this x equals -3, that line. What that means is that no matter what, my x value is going to be -3, and my y value can be anything. So for Mrs. Hong's class, we talked about, can a student labeled -3, can he or she have all these different grades? No, so this would not be a function. It doesn't pass the vertical line test. So tables is the next thing, and tables is I think it's super fun because you can look for the rate of change, which is, in a linear function, the rate of change is always constant. We say the rate of change is the change in y over change in x. It's also known as the slope, right? M stands for slope. It's slope, it's also rise over run, right? On a graph, I always go rise over run. So here's what we're talking about when we're talking about rate of change on a table. Rate of change is a change in y over change in x. So we want to see what is happening to x every single time. That's my change in x. We also want to know what's happening to the y every single time. So we notice here that there is a pattern. The rate of change is change in y over change in x. So the first two pairs of points, we see that the change in y is 4, change in x is 1. The second pair of points, we see again it's 4 over 1. The third pair is also 4 over 1, and the fourth pair of points, the change is 4 over 1. So because all of them are equal, 4 over 1, 4 divided by 1 is 4, so we know that the rate of change on this is 4. Now on the second table, we see that the change of x, they are not the same. It's going up by 2, it's going up by 4, it's going up by 3, but we got to double check and see what the change of y is doing. We see a -4, -8, and -6. So between the first two pairs of points, we see that the rate of change is -4 over +2. The second and the third pair of points, we see that the rate of change is -8 over +4. And the last two, we see it's -6 over +3. Well, if I simplify all those, I really get -2. So the rate of change is constant. The rate of change is -2 throughout. So this also would be a linear function. So here's another table, and we want to figure out if it's linear. I want to find the change in x. So I see it's going up by 5, going up by 7, going up by 1, going up by 2. On the change of y, I see that it's going down by 3, down by 6, down by 12, and down by 6 again. So if I were to find this rate of change, it's -3 over 5, -6 over 7, -12 over 1, -6 over 2, and I see that none of these are equal to each other. So no, this rate of change is not constant, so it would not be a linear function because these are not all the same. So I'm going to do the same thing here, finding change of x, -6, -2, -4, -8, change in y. I get -15, -5, -10, -20. So I need to know if this rate of change is constant. So I've got the change in y over change in x, -15 over -6. I've got the second and third pair of points. It's -5 over -2. I get the next one to be -10 over -4. I get -20 over -8. I need to figure out, is this rate of change constant? Well, I see that the first fraction I can divide by 3, and a negative divided by a negative is a positive, so I get 5 over 2, which equals 5 over 2. And divide by 2 on both of those, and I get 5 over 2, because a negative divided by a negative is positive. Both those numbers can divide by 4, so I get 5 over 2. So throughout the table, the rate of change is constant. So yes, this is a linear function. So when it asks to describe these functions, I'm going to say function A. Well, reading the graph from left to right, I see that function A is decreasing, right? The rate of change is going down. I also notice that it has a constant rate of change because it is a straight line. And I also notice that it's a linear function because of all those reasons that we just said. Function b. So I'm going to describe function b. I also notice that function b from left to right is increasing. It's going up from left to right. And then I also notice that because it is a straight line on a graph, it also has a constant rate of change. And because it's increasing at a steady rate, I know that this is a linear function. So I'm asking for similarities and differences. I always want 2 of each. So the first similarity I see between function a and b are that they're both functions are linear. And I also notice that because they are linear, both functions have a constant rate of change. So for 2 differences then, I notice that function a is decreasing while function b is increasing. And because those are different, I notice that the rate of changes are different because the function a would have a positive rate of change and function b would have a negative rate of change.